Hello, and welcome to Solving with Exponents Day 2. We're not doing any new information, really. I'm not introducing any new rules. I'm just practicing some more problems with you, and they may be slightly more difficult than the problems we've done so far, so make sure that you're following along. I am going to be freehanding this. However, if you take a look on Canvas, I'm pulling these questions from a few different worksheets, and I've put the answer keys to these worksheets on Canvas, if you'd like to take a look. Let's get started. So the first problem I'm going to do with you today is 4 to the x plus 1 is equal to 16. So there's a few different ways that you can do this problem. First, you can make these both be a base of 2 and change the exponents accordingly. Or, since 4 will also work for both of these, you can change this, be the 4 to the x plus 1 is equal to 4 squared. So some people may change this to a base of 2, some people may change this to a base of 4. Either will work as long as they are the same base. Just make sure they can be the same base. But from here, we can cancel out our bases. Get x plus 1 is equal to 2. Subtract 1 on both sides. We get x is equal to 1. Please make sure you put your answer into a solution set, and you're good to go. I just want to talk about the base thing with that one. That one went pretty fast. Let's try another one. I'm going to go to the side over here. Let's try, let's see, 3 to the x squared minus 7 is equal to 27 to 2x. That one looks much more exciting. So let's see, 3 can't change that base, but 27, we can change that into a base of 3. So we're just going to say this is 3 to the x squared minus 7 is equal to 3 cubed to the 2x. Now we need to use our power rule and multiply those exponents together. So we get 3 to the x squared minus 7 is equal to 3 to the 6x. Now that our bases are the same, we can cancel the bases and set the exponents equal to each other. So we've got x squared minus 7 is equal to 6x. We have something with an x squared, something with an x, something with a constant. I'm probably going to have to factor. So let's set this equal to 0. Get x squared minus 6x minus 7 is equal to 0. And now we're looking for two numbers that multiply to negative 7 and add to negative 6. And that is going to be, let's see, x minus 7 times x plus 1 is equal to 0. I need to set each of these factors equal to 0. So x minus 7 is equal to 0. This one is equal to 0, and we get x is equal to 7, and x is equal to negative 1. I'm going to take these answers, put them into a solution set. Please remember to put them in order from least to greatest. It's going to be negative 1 and 7. So there's 2 out of our 5 problems that we're going to be doing today. Hopefully, the more you practice, the faster these will go. So let's try another. I'm going to move this up. Okay. The next problem is going to be 4x squared. My bad. 4 to x. It's 4 to the power of x squared. There we go. Is equal to 2 to the x. Now, just a reminder, I'm not going to make bases larger. So I'm not going to change 2 into a base of 4, but I can change 4 into a base of 2. So we're going to make this 2 squared to the power of x squared is equal to 2 to the x. I'm going to use my power rule, multiply those together, and I'm going to get 2 to 2x squared is equal to 2x. Excellent. My bases are the same. I'm going to cancel those out. And I'm going to get 2x squared is equal to x. Here's what I'm not going to do. I'm not going to divide both sides by x, because if I divide both sides by x, one of my answers will go away, and I don't want that to happen. So instead, I'm going to subtract x on both sides, get 2x squared minus x is equal to 0, and then I'm going to factor out an x. So we're going to have x times 2x minus 1. And now I have 2 factors, and I can set these both equal to 0, just like we did in the previous problem. So we get x is equal to 0. We get 2x minus 1 is equal to 0. If you had gone through and divided both sides by x, you would have missed this solution. So please, please, please do not divide by x. But let's keep solving with the other one. So let's add 1 to both sides. 2x is equal to 1 divide both sides by 2, we get x is equal to 1/2. So when I put both of my answers into a solution set, I get, let's see, we get 0 and 1/2. So again, please don't divide by x or else you're going to miss one of those solutions. Okay, so our next problem is going to be dealing with all the fractions. We're going to have 2/5 to the 3x plus 5 is equal to 625 divided by 16. So I take a look at this, I go, ooh, fractions. Okay, well, I know that I can turn 16 into a base of 2, and I can turn 625 into a base of 5. So I'm going to do that. So I'm going to say that this is 2/5, 3x plus 5 is equal to 5 to the power of 4 divided by 2 to the power of 4. Okay, there's another exponent rule. We haven't covered it, but it's similar to the power rule that says that we can just set the second fraction of 5/2 to the power of 4 and not have to do it individually. So we can say that 2/5 3x plus 5 is equal to 5/2 to the power of 4. Now, here's the problem. The bases have to be the same, and we're really, really close, but we're not quite there. We need to find a way to switch this 5 and this 2. And a way that we can switch that is if we put this to the power of a negative exponent. So instead of making this 4, we can make this -4. The step I'm about to do, you can combine the next two steps if you want. But I'm going to say this is 2/5 times 3x plus 5 is equal to, I'm going to double parenthesis here. Pardon me, we're switching that fraction. 2/5 to the -1. So I've switched that fraction, I've flipped that over to the power of 4, and then I can use my power rule to multiply those exponents together. So we're going to have 2/5 to the 3x plus 5 is equal to 2/5 to the -4. So this is using your fractions, this is using some of your exponent rules in ways that you may not have seen before or practiced before. So now that we're here, it's like, oh cool, our bases are the same. We can cancel those out, and now we can just set the exponents equal to each other. So we'll have 3x plus 5 is equal to -4. I'm going to subtract 5 on both sides, so 3x is equal to -9. Divide both sides by 3. We got x is equal to -3. Make sure you put your answer into a solution set. So once you can get the bases to be the same and cancel those out, it's usually not too bad. But from here, it may take a couple steps to do that. That's okay. So let's try one last problem. Now this problem has two different ways of being solved, or probably more than two ways of being solved. The way that I did it on my answer key took a pretty long time. It's on the solving exponential equations homework. It's problem number 10 on there. In this video, I'm going to be solving it in a shorter way. But I want to just let you know that if you do look at the answer key, you may be seeing something slightly different. So let's see, this problem is 1/4 divided by, look at all them fractions, 16 to the 3x plus 1 is equal to 16 to the -3x minus 2. So this one is a lot, and we can tell. So the way that I did this on my answer key that you'll see is I changed everything to a base of 4. I wrote the left side the long way. I changed a lot of things. It happened. But a few years ago, a student pointed out to me that we can multiply both sides by the denominator. So I'm going to multiply both sides by what we see right here. So if I do that, that's going to be 1/4 is equal to 16 to the -3x minus 2 times 16 to the 3x plus 1. And I'm like, oh, this goes so much faster. Now we can change our bases to be the same. We can say that this 1/4, that's the same as 4 to the power of -1, so using your negative exponent rule. Let's see, this 16 becomes 4 squared. The the negative 3x minus 2, and this 16 also becomes 4 squared to the 3x plus 1. You can also change all of these to a base of 2 if you like, but changing it to a base of 4 is perfectly fine. So from here we're going to use the power rule and say that 4 to the negative 1 is equal to 4 to the negative 6x minus 4. Please make sure to distribute that 2 to all pieces of the exponent, times 4 6x plus 2. Now here's what you don't want to do. You do not want to cancel out your bases yet. Even though all of our bases are the same, we have to simplify this side as much as possible before we can cancel anything. So if I have two bases that are the same being multiplied, it means we're going to add their exponents. So this is going to become 4 to the negative 1 is equal to 4, let's see, negative 6 plus 6 gives me 0. Awesome. Let's see, negative 4 plus 2 gives me negative 2. I'm going to cancel out my bases, and we're going to get negative 1 is equal to negative 2, but that's not how math works. We can't actually use that. So if you come across something that doesn't actually work, it just means that in this case, there's no solution. And the way that we write that in a solution set is we use something called the null, or the null set. So it's not just a 0, it's a 0 with a line through it. Now I know that some people use that as just kind of their handwriting when they're writing a 0, but that's not what that means. The 0 with a line through it stands for null or empty. This is the empty set, and you only find an empty set when there is no solution. So please make sure that you notate that accordingly. But here was just a few more problems to practice. Please check out the Solving with Exponents Day 2 Go formative, and I look forward to seeing you tomorrow.